Do you remember what we have learned back then in topic 4 about gas law? Have you ever wondered how we can apply the gas law to real life situation?
In this video, we will be showing you in details how can we relate the real life situations with the gas law, which are Boyle's law, Charle's law, and Gay-Lussac law. Let's go.
So what is Boyle's law? So Boyle's law states that the volume of fixed amount of gas is actually inversely proportional to its pressure at constant temperature. As one variable is increases, the other variable is decreases. So this means as the volume is increases, the pressure is decreased. As you can see in the graph, as the pressure is increased, the volume is decreases. As you can see from the picture above, and my right hand shows that as the volume is decreased, the pressure is increased. Meanwhile, on the other hand, as the volume is increased, the pressure is decreased. By using above formula, we can actually find the volume resulting from the change in pressure and vice versa.
Now let's see how can we apply Boyle's law to the real life situations. We're going to see the demonstration of this law through the operation of syringe, but using a marshmallow. And all we need is a syringe and a happy marshmallow. Firstly, you put the marshmallow inside the syringe, and then you push the air up, and then you cover the hole with your finger. And then you pull back the plunger, and you can see the marshmallow expands. And then if you push down back the plunger, you can see the marshmallow shrinks back. This is an example of the Boyle's law, which states that pressure is inversely proportional to volume. In other words, if we pull the plunger, the pressure decreases and the volume increases, causing the marshmallow to expand. And when we push down the plunger, the pressure increases and the volume decreases, causing the marshmallow to shrink in size.
Hi, I'm Izzati. Now I'm going to share with you about the Charle's law. Do you recognize this figure? He is Jacques Charle, the mastermind behind this law. Charle's law states that the volume of gas is directly proportional to its temperature, provided that the pressure stays constant. The relationship is described by the formula V1 over T1 equivalent to V2 over T2. Let's visualize with a lab setup. Imagine we have a gas trap in a cylinder with a movable piston. When we heat the gas, the temperature increases. You can see at the graph here. As the gas particle gains energy, they move faster and collide with the pistons more frequently, pushing it upwards. And this causes the volume of gas to expand.
Now, let's move to the application in our real life. First thing first, let's see this video. So, from this video, we can see that the cake rises after heating in the oven. What happens when the cake rises? Inside the cake, there are tiny air pockets or bubbles that created by mixing or adding baking agent, such as baking soda. So, as the cake heats in the oven, the temperature of the trapped air increases. According to Charle's law, when the temperature rises, the volume of the gas in this bubble expands. So, the expanding gas pushes the cake outwards, causing the cake to rise and become fluffy.
Next, we will talk about Gay-Lussac's law. Have you ever wondered what happens to a gas when you heat it up? Gay-Lussac's law explains how pressure and temperature are related for gases. It states that as the temperature increases, the pressure also increases, as long as the volume is constant. Here is the example of experiment that are using of concept of Gay-Lussac's law. If the temperature increases, the pressure also increases, but the volume will be constant.
Picture this, when the gas is heated, its molecules move faster. The increased movement leads to more frequent collision with the container of the wall, which creates higher pressure. So when the temperature goes up, the pressure increases, as long as the volume doesn't change.
The real-life example is a pressure cooker. When it heats up, the temperature inside increases, causing the gas molecules to move faster. This raises the pressure inside the cooker, allowing the food to cook faster due to the increased pressure.
Another example is your car tire on a hot day. As the temperature rises, the air inside the tire heats up. The molecules inside the tire move faster, which increases the pressure inside the tire.
That's all from us. Thanks for watching. Keep learning about the amazing world of gases with us.